silicon crystal, the band gap is like this. After doping aluminum, we can see the green stays there, and the lumo is around the humor of the silicon valence band. And from the right, we can see the phosphorus doping into the silicon crystal. We can see the humor of phosphorus is nearing the conduction band. So here we show when we doping the two elements into this crystal, we will narrow the energy gap of p-n doping crystal. Here we use the VASP to calculate out the density of states left and the absorption spectrum right. So we can see clearly the HOMO of the crystal is contributed by the aluminum of LUMO, and the LUMO of this crystal is contributed by the HOMO of phosphorus. And from absorption spectrum, we can see big peak around energy 4.5. It's contributed by here the crystal absorb light, then the electron transfer from here to here. So actually the absorption spectrum contributed by two important parts. One is the orbital should overlap. So these two parts, the orbital overlap, which I didn't show here. Another thing is the oscillatory strength of the two band. So we got the absorption spectrum, and we calculate out the positive. We remove one electron from the crystal. Then we calculate the density state and the absorption spectrum. So we can see from the humor of the crystal, there's a hole there. See here, a hole there. So this this means we remove some electron. When we add one electron into the system, we can see some electrons come into the lumo of the crystal. And we see a little change here is the no energy transition. We from us we know that the transition some of come from the valence band into the the transition here contribution by the electron here to here. So the energy distance is not high. And we heating the quantum dots to 200 K. So we see that the density of states change a lot. It means the crystal structure may be changed. And from absorption spectrum, it also changes a lot. And we see the structure of the crystal. We see that it's almost destroyed. And the distance of phosphorus and aluminum increase a lot in the following table. And we create a movie how this process happened. So we can see, here, we can see the crystal after heating from 0 to 2000, it's destroyed. And we upload this movie into YouTube. You can search it. And here we excited the electron from HUMO to LUMO. We trying to see what happened here. So from density of states, it's easy to show that from HUMO some electron transferred to the LUMO. Here is the absorption spectrum. And from partial charge density, we see some charge density located around the aluminum in HUMO, and some of density located around the phosphorus in LUMO. So here, almost same as before, we can see the LUMO is contributed by the HUMO is contributed by the LUMO of aluminum, and the LUMO is contributed by the HUMO of phosphorus. So the band gap ladder. This is the summary of our calculation. You can see here the distance between aluminum and phosphorus after heating 2,000 degrees. It's a break. So the conclusion is when we doping the aluminum and phosphorus, we added some new band structure into the quantum dots. Another is the transition between this band as shown in the spectrum after we calculation.
Okay, thanks.